Hello, everyone. Thank you for having me here. My name is Ken. I'll be talking about Rubrik and AWS and Cloud Native Protection Solution. So I am a multiple-time Cloud Tech Field Day watcher, first-time presenter. That's the proper response. So a little bit about myself. I am a technical marketing engineer here at Rubrik. There are a couple of ways you can reach me on social media, mostly through Twitter. As Chris mentioned, I blog at cloudarchitectmusings.com, where I blog about not necessarily Rubrik stuff, but just generally about technology specific, particularly around public cloud and about cybersecurity. And my background is I've worked at a number of places, both on the end user side and also on vendors and service provider. Most recently, prior to coming to Rubrik, I was a cloud architect and then a technical marketing engineer at Rackspace, specializing in OpenStack and in AWS. So as I mentioned, we have many cloudy features. And what I want to talk about specifically today is AWS native protection. Again, a familiar slide from the last presentation. This is what we see around customers' cloud journey. Andrew's focused on phase 1 with cloud out. I want to focus on phase 2 and a little bit into phase 3, which is the idea that once customers have some comfort level with public clouds and they've moved some of their data up, they might want to start moving some of their workloads up to the cloud, whether you call it lift and shift or move and improve. Or they may, in some cases, be building brand new now cloud-native applications using the services that are provided by that particular public cloud provider. So obviously, as our customers are doing this and they're building these new applications in the cloud or moving workloads to the cloud, we want to enable them to protect their workloads and their data. And the way I want kind of to frame up what we're doing around AWS, I want to frame this up to talk about Rubrik Cloud Data Management as not just a software feature, but a platform on which we're building out portfolio services and solutions that we think can help customers with their data management needs in the cloud. And we're taking the approach that we want to build out why. So we're supporting AWS, Azure, Google Cloud, and whatever else may come next, depending on customer demand. And as we're integrating with each of these public cloud providers, we also want to start building deep and building up the stack to provide more services to protect cloud workloads wherever they may sit. So we already talked about cloud out, protecting data into the archives. I think Andrew briefly mentioned cloud on, which is our ability to take that data that's been archived and then spin it up in this case, AWS and Azure, as to provide a replica of your on-prem environment. Looking to do that in the future with Google Cloud. And then we also provide the ability by spinning up Rubrik as a cloud cluster instance where you can back up the guest OS and any databases that are running in those guest OS. So that's kind of where we've been today. And then we also want to continue building upward. So today, I'm actually going to go through a technical preview on a solution we are introducing around supporting data protection, elastic block volume in AWS. As you can imagine, over time, we plan to extend that to the other cloud providers that we support. And then beyond that, it's whatever the customers tell us, right? Could be some things you probably would look at is RDS in AWS, maybe Cloud SQL Database, even DynamoDB and the like. So that's kind of the way I hopefully can frame this up, that this is, again, not just one single feature, but really part of a portfolio of services that we're building at Rubrik. So kind of the natural question is, why do we need to protect cloud-native apps, right? We've been told for years, you don't need to protect the data. These are all ephemeral containers or serverless. So I want to hopefully, if you're in that camp, whether you're sitting here or watching in, I want to hopefully convince you that it's actually important to protect data, even if it's cloud native. So first of all, cloud native apps are stateless until they aren't, right? So it's one thing to run a bunch of WordPress sites in a container. It's another thing to run your production database. At that point, somebody, some way, has to store that data somewhere and protect it. And that's what protecting state is all about, right? Storing and protecting your critical data. Also, protecting state is always someone else's problem until you're an admin, they say it's your problem, right? And the group we can kind of blame for that a little bit is Heroku and what they talked about with 12-factor apps. So if you're all familiar with that, one of the things that Heroku talks about in that 12-factor app manifesto is don't worry about state. Everything should be stateless. And I think what my personal opinion is there's some misunderstanding around that because people have lost the context or where Heroku came from. They were, in fact, a PaaS platform built on top of a public cloud. So what they were saying wasn't that state wasn't important to store. What they were saying is storing state, it's someone else's problem, specifically the public provider that they're running Heroku on.
Isn't there another one that states something about that? You should still have a persistent backing store for your app at some point.
Right. Well,
Number 6 or whatever it is,
yeah.
I think says something like that.
Essentially, they all have to do that. I think the question is that something you worry about?
Yeah.
Is that someone, the public cloud
And I think that's the reason why they describe it as a backing store, because it isn't your app doing it, it's the platform that's doing it.
Whether it's a database or
Yeah.
volume. But the reality is, right, as people have started trying to build cloud-native apps, they're either trying to build that on premises, so they're not even using the public cloud, or in many cases, we have customers who are running in the public cloud, but they're not quite ready to buy into all the higher level services like relational database service or Spanner or Cosmo DB. And they actually, in many cases, customers are running their own databases, right? In which case, they are now responsible, those admins are now responsible for protecting that data and not the cloud provider. And then finally, if you look around, it seems like everyone's running containers. But when we talk to our customers, they're almost all running virtual machines. And whenever you run virtual machines, there's state that has to be protected, right? Very few people are running virtual machines, even in the cloud, that's completely ephemeral or immutable, where they can just blow away those virtual machines and start over. They need to be able to protect the state of that machine so they can recover it in the event of a disaster. And that's what we're seeing on our customer base. And so we wanted to make sure that we had a solution that would be able to enable them to kind of have a peace of mind around running their workloads in the cloud. And that's where AWS EBS Snapshot Integration comes in. So one of the things that we did in working to bring this to market is we wanted to take the approach, similar approach that we're taking with on-prem virtualization environments, which is we don't want to reinvent the wheel, right? We don't need, in the case of VMware and Hyper-V, for example, we leverage the native snapshot integrations that exist and back up those snapshots. In the same way, we didn't want to take the approach of let's build a brand new snapshot technology just for AWS or just for Azure. We wanted to integrate with what was already existing, but make it simple and easy for customers to operate. And one of the side benefits of taking that approach, where we're really just orchestrating backups in a way that's simple for customers to use, and talking to the APIs underneath, is we can actually manage EBS snapshots running in AWS from an on-prem Rubrik instance, or by running Rubrik on AWS as a cloud instance, reaching out to EBS volumes in various regions. Any questions so far?
Just on the slide you showed with what you can currently do, the guest, is that using an agent where what you're previously?
Oh, oops, sorry. This one, right?
I didn't mean to make you go on.
Yeah, okay. Well, so I think it's the Guest OS one.
Yeah.
Yeah, so that one, currently today, it is an agent installed on the Guest. Again, that's for customers who want to do file set backups, and also maybe they don't want to buy into.
No, I understand that. It's just level set for the next stages.
Sorry. Okay, so before I kind of dive into exactly what we're doing and demo how we're integrating with EBS Snapshots, I thought it would be helpful if we actually just do a very quick overview of what EBS is. So Elastic Block Storage is a fairly old service within AWS. Essentially, it is a way to provide a logical block volume, right, that's backed by a host of physical disks, and present them with an API. So a customer can very quickly provision that storage and attach them to instances over the network. And the key thing to remember about Elastic Block Storage, it is persistent storage. So prior to this, if a customer is using hard drives that were inside of the hypervisor, the minute not even do they terminate the instance, but the minute they stop it, all the data was wiped clean. So by using elastic block volumes, they're able to, for example, stop or terminate an instance, detach the volume, and then reattach that volume to another instance. So it's a way to keep that data around long term. And elastic block storage can be either SSD or magnetic disk. So there's a couple of different options. And then snapshots are basic. So EBS today is it's resident within a single availability zone, but replicated to multiple storage systems within that availability zone. So that could be actually across 2 to 3 data centers. But it's not something that's available to another region. So if you're running an elastic block volume in Northern Virginia, that block volume isn't readily available, say, in Northern California. So one thing the snapshot can do is it takes a point-in-time copy of that snapshot, and saves it as an object within S3. And S3 itself is a regional resource. So now from any availability zone within that same region, you can access that snapshot and create a block, the volume. But you can also copy that object, that snapshot, over to a different region and be able to launch volumes from there. So it gives you a bit more portability. And also, again, gives you a way to basically protect your data, a point-in-time copy of your data. Makes sense how this works? Pretty similar to some of the stuff you do on premises, but with kind of the regional aspects thrown in. So what are some use cases for EBS snapshots with Rubrik? Why, if these primitives are already in place, why do people want to ask Rubrik to help them with this? So the first and probably the predominant use case is the way AWS has approached this is they've given you the primitives to create these volumes and use them, but everything is a manual task. And one of the things customers talk about is they don't want to have to manage their snapshots the way that they have to manage the rest of their environment. So an example is, today there is no easy way natively to schedule snapshots or to expire them. So we have a lot of customers who tell us they essentially have snapshot sprawl, where they've got thousands upon thousands of snapshots that they can't easily manage and be able to expire when they're no longer needed. Second use case is just being able to do a recovery very quickly. One of the things I'm going to show you is in AWS, actually restoring an EBS volume is not a trivial process. Typically people will script that process, but then now they're managing a tool that they've created to automate that process. We're basically automating that for them so that they can recover more quickly. And then I mentioned before, another use case, people want to be able to copy snapshots across different availability zones and regions and want a single place where they can manage that and schedule that.
How much of this, kind of an odd question, how much of this is capable across providers?
So different providers have different capabilities. And so one of the value props we're hoping to bring is, whether you're running an AWS, Azure, Google Cloud, they each have their own approach to doing this. We'll basically normalize that and say, you use Rubrik, is pretty much the same process and the same API calls.
But does that mean that then you could potentially pull data out of one and put it and essentially back it up to a different one?
Not in this case, so because we're actually leveraging the native API. So right now we're doing EC2 API calls.
Right.
If we were in Azure, we would be leveraging whatever they do around Azure Disk.
But,
so it's different. So we don't really move the data between them.
Right. The reason why I'm asking is because there is this concern about putting your eggs in one provider's basket, even if you are across different regions, across AZs or whatnot. It just kind of popped to my head. Could this be a means to potentially get around that, right?
Yeah.
By using Rubrik as the glue between different providers.
Yeah, I don't think we're so much doing that as we're hopefully abstracting away some of the complexity. So not necessarily from a data movement standpoint, but from a skills standpoint. Like instead of having to say, well, we can't move to Azure now because all our people only know AWS. You can say, if you know Rubrik, you may know enough that you can now switch over to Azure, to Google Cloud, and still be able to continue running your data protection.
Right, so you've abstracted the
Yep. data
data management layer into Rubrik,
Yes.
so you don't have to directly create the snapshots or run your PowerShell
Yeah.
scripts to do the snapshots. But I think the more important thing, or the thing I would really like to see, is take that native EBS snapshot, crack it open, pull the data out, and then use the replication technology to replicate that information somewhere else. In the same way that you do on-premises data management, you're cracking open that VMDK, pulling the information out, and then you can restore it to a cloud VM or anywhere else, basically.
Yeah, we're doing some things around file indexing. We're going to crack open the EBS volumes. I don't know if we're doing that specific use case you're talking about.
So what I do, like it sounds like though, even with the normalization of the APIs, if I have a orchestrator inside of my data center, and I've exposed, let's say, data management policies to my application team or my DevOps team, I can now normalize that eventually across cloud providers.
Exactly.
So I can say this is the policy regardless of the cloud provider, and now you guys can orchestrate that and hide that complexity from my internal DevOps team. Even.
Yeah, let's think of it as a very similar approach to where Andrew talked about cloud archives, where it's a similar process and tooling to manage multiple clouds. So we don't have to relearn kind of new skill sets to be able to use a different cloud provider. Let me move forward. So the last one is kind of things I already touched upon, right? Having a common tool to use to manage your, whether it's on-premises or running in an AWS, and in the future, Azure and Google Cloud. So I'm going to show you some things. Again, keep in mind it's a technical preview. It should all work. So I want to show you how easy it is for us to discover the environment, how we can schedule snapshots, and how we can apply lifecycle management policies to those snapshots in a very simple manner. So what I'm going to do, run here. So I'm running in this lab Rubrik, and you'll notice that we have a section called Cloud Workloads. Click on here, and currently I have 3 instances in here, but you'll notice these 3 instances are actually running across 2 different AWS regions. And all I had to do to discover was I went to Accounts. I'm actually going to modify this one. So if I was creating a new cloud source, in this case, we'd give it a name. I would give it basically the access information for a service account that has permission to an ownership of the EBS volumes and to be able to make EC2 API calls. In this case, I can choose what regions I want to discover and bring under management. So in this case, I'm going to add US West 1, hit update. So it should take a minute. You'll see now, instead of 3 instances, I have 5, including US West 1.
Do you have a sample IAM policy to be able to just apply the permissions you need in AWS?
Right, today is an actual IAM account with using an access key. So we've talked about doing roles, but that's not something we have today.
And in terms of the IAM policy for what that account has access to, do you have that like pre-written? So
yeah, so that's at GA, in our documentation, we'll specify what IAM policy needs to be attached to that particular account. Because there are other things to be concerned about, like because there's an encrypted volume, there's certain policies that has to be in place so they can read the encryption keys. All right, so at this point, let's take a volume, one of the EC2 instances I found in US West 1, and I'm actually going to take it, this is a new environment, so I'm just going to take an on-demand snapshot, apply a domain, and I'm going to go back a little bit and talk about domains later, and take an on-demand snapshot. And if I go to the console and go to snapshots, you see that so essentially I just made an API call, create a snapshot for a instance running in US West 1. So that's pretty simple. That's actually a pretty simple thing, even if you were using AWS native calls. What's more interesting, though, is what if I was doing something more complicated, like restores. So let me kind of go back here. So I don't know how many of you are familiar with AWS, but these are essentially the steps are required to do a restore from a EBS snapshot. And this is the case whether you're running through the console, whether you're doing the command line, as I'm doing here, or even you're making scripting it using API calls. It is an completely iterative process where you have to tell it, I'm going to create the volume, I'm going to stop, detach, attach, restart, right? And so there's some skill sets required. You may script this thing, but now someone has to manage that script, and it's a whole product feature now that they have to do. So I'm going to show you how easy it is to do a restore. So let me go back here. And just for the sake of time, I will go to an instance I already have. Snapshots is already done. Let me see, US West 2. So I've got a number of snapshots here. So I'll go to one from April 1st. And click here, you see that I can just do a restore. Hit the restore button. Give it a second. And you see it launched. So now I'm going to go to US West 2 in Oregon. I go under snapshots. Oops. Sorry. Oh, okay. Oops. Okay, it's probably taking a minute to basically make the API calls. But again, what it's going to do is going to restore the volume. It's going to create a new volume from a existing snapshot that I've chosen, stop the instance, detach the volume, and then reattach it.
So Ken, one of the pains of doing the EBS attaching is stopping the instance. Are you guys going to at some point on a roadmap have a place where I can restore to a temporary instance, mount it on a temporary instance, and then restore it to the original location?
So yes, so we'll have a way for you to create a new instance off the snapshot. Mm-hmm. So, okay, actually here, sorry, I was actually at the wrong region. So in Ohio, you see that a new volume was created. And that, sorry, if I go back here, and it might be hard to, let me see if I can make this bigger. You see now that volume is attached to CFD01, which is the machine I was trying to restore the volume from. So the 4 steps I told you about, that was all done by basically one click or by one API called via Rubrik.
And can you control what tags are associated with that restored volume?
Yeah, so in the GA version 1 will not have tag support. That's coming shortly after. So
what about discovery of existing EC2 instances and EBS volumes? Can you say, if this volume has this tag, I want you to discover it and then back it up with these retention
So again,
policies?
that's when we have tag support, we'll be able to do that. Okay. In this case, what you saw was I went in and did a discovery of a particular region. Mm-hmm. They pulled every instance off that region. It doesn't necessarily automatically protect that instance. I still have the choice of saying I protect some instances, not others, but it won't automatically do it via tag yet.
Right, but you see where I'm going. Like,
yeah, absolutely.
If my developers spin up a VM, they can select what backup SLA needs to be associated with that, and Rubrik just grabs it.
I'm a huge believer in tagging.
Yeah.
Everything should be tagged. So.
Can you go to the just for time's sake?
Yeah.
The summary so we can keep it rolling.
Okay.
Good question, but I didn't want to hold it.
Yeah, sorry about that. Let me run through this. Let's see. So let me talk about a couple of things. One is that, so again, our focus is really around trying to simplify data protection tooling, right? So you saw the process it took just to do a restore and to maybe take that volume to another region. all that's either done today manually or through a script that you put in the cron job, or you're using potentially something that AWS provides, but those will require you to know a number of services. So now you're getting deeper into AWS, and you need more people who know AWS. What we're trying to do is say, if you know Rubrik, you know how to manage snapshots in AWS, and you will know how to manage snapshots in Azure and Google Cloud.